All right, Math 1, this is your EOC review number 3. So we have EOC review 3, and this is systems of equations, okay? EOC reviews 3, system of equations. This is note card 14. All right, so a system of linear equations is going to be more than one equation. So we got systems of linear equations, or where you have more than one equation. It's more than one equation. To solve a system of equations, when you're finding a solution to a system of equations, what that means is what points do they share? So, in other words, when you're solving a system, you're asking yourself, what points do they share? Remember that if we're talking about straight lines, there are only 3 types of solutions that you can have. The first type of solution, this is your X, this is your Y. The first type is if the lines cross each other, then there's only one solution. Why is there only one solution? This one point is the solution because that's the only point that they share. Okay? So there's one solution here. This is the one solution, the point that they share. There's no such thing as 2 and 3 solutions with straight lines because the lines don't loop back around and touch each other again. They touch in one location, or the second type of solution that they can have is that if the lines are parallel. If the lines are parallel, then there's no solution. So parallel lines, if you were to graph them, they do not have a solution. There's no solution to parallel lines. Okay? And the last type of solution when it comes to straight lines are if the lines, if you graph them and they happen to be right on top of each other. Do you see? That's why I'm putting two sets of arrows. They share all the same points. By definition, a line continues without end. So since they share all the same points, there's an infinite number of points. So this is infinitely many solutions. This is infinitely many solutions. Okay? And that's note card number 14. This is note card, slide this down a little bit. This is note card number 14, okay? All right. Note card number 15. Again, at the top, we're going to write EOC review. 3, systems of equations is the title of this review. All right, so with EOC review number 3, this is note card number 15. Here we're going to talk about the graphing method. Okay, so we're going to be, when you're using the graphing method for solving a system of linear equations, you are basically graphing to see what points they share. Okay, when you graph to see what points that they share, the equations must be written in slope-intercept form. So equations must, what I'm getting ready to write, must be written in slope-intercept form. Remember that slope-intercept form must be written in slope-intercept form to graph. Super important. Slope-intercept form is y equals mx plus b. Okay? So let's suppose the example, I wanted to graph this system, or if I wanted to solve by using the graphing method, you have 5x plus y is equal to 9, And you have the other equation, 10x minus 7y is equal to a negative 18. All right. Both equations must be written in slope-intercept form. I'm going to rewrite the first equation, 5x plus y equals 9. In order to write this in slope-intercept form, I've got to subtract the 5x on both sides. This gives me y is equal to a negative 5x plus 9. Now you can graph this because your m is negative 5. You got negative 5 over 1, rise over run. And you got b is 9. You can graph that now, okay? Find 9 on the y-axis. Use rise over run to graph, to put points on that line. Now you have the second equation, 10x minus 7y is equal to a negative 18. The first thing you're going to do here to put this in slope-intercept form is move the x term. So this is gone, and now I'm left with negative 7y is equal to a negative 10x minus the 18. Now I'm going to divide everything by a negative 7, okay? So now I get y is equal to, a negative divided by a negative is a positive 10 over 7x. This is a positive 18 over 7, okay? So I would probably change this to a decimal, or you can use the calculator to graph it, okay? But you can graph this, all right? You can graph this. So now you can graph both of these. This is your M, this is your B, all right? And see where they cross, okay? The next one, card 16. Card 16 is, at the top, we're going to put, again, EOC Review 3. The title is Systems of Equations. Okay. And we're going to do substitution method on this one. So with the substitution method, you're using algebra here. So you use algebra to find the solution, or what points, or where the lines cross, or what points those lines share, okay? To find the solution or where line cross. Okay? All right, so this is an example. You got negative 5x plus y is equal to a negative 2. Negative 3x plus 6y is equal to a negative 12. All right, so to use the substitution method, the first thing that you're going to do is isolate one of the x, either the x or the y in either one of the equations. This is the easiest to isolate. The y is in this first equation because there's nothing in front of that y. Okay, nothing is attached to the y. So I'm going to rewrite the first equation and isolate the variable y. So I'm going to add 5x to both sides. This is 0, and I'm left with now y is equal to 5x minus 2. That's the first step. Y is now isolated. So I'm going to substitute this for y in the other equation, okay? So I'm going to write the other equation. Negative 3x plus 6y is equal to a negative 12. I'm going to replace y with this expression, with what y is equal to 5x minus 2. So it's negative 3x plus 6. This is multiplication here. So that's times 5x minus 2 is equal to a negative 12. This is negative 3x. This is plus 30x. This is minus 12 is equal to a negative 12. Okay? So now, combine like terms. This gives us 27x minus 12 Okay, bring everything else down on the other side. To get x by itself, you add 12 to both sides. So this is going to be 27x is equal to 0. I'm going to divide both sides by 27. So now what I have here is x is equal to 0. All right. So now my x is 0. So now I got to figure out what my y is. So I'm going to choose one of the equations. I think the easiest equation to use is going to be the first one. So I'm going to rewrite the first one. Negative 5x plus y is equal to a negative 2. I'm going to substitute 0 in for x to figure out y now. So that's negative 5 times 0 plus y is equal to a negative 2. When I multiply this gives me 0, and I'm left with just y now. And y is equal to negative 2. So my ordered pair is 0, comma, negative 2. This is going to be my solution. This is the solution there. Okay? So that's how you do the substitution method. Okay? Now we're going to do elimination method. So this is the 17th card. Okay? This is the 17th card. Again, we write EOC review. This is EOC review 3, systems of equations. And this is card 17. Okay? Elimination method. The elimination method is where you're going to use addition, subtraction, or multiplication to cancel out one of the variables, and then use substitution to find the other variable. So elimination method is where you're going to use, addition, subtraction, or multiplication. This means multiplication, okay? To cancel out one of the variables. You're going to see if you can cancel out one of those variables first, either x or y, and then you're going to use substitution. You're going to use substitution to find the other variable. Okay? All right, so this is how that works. Okay? So we have 5x plus y is equal to 9. And we have 10x minus 7 y is equal to 18. Okay, so now this is how you do this one. All right, so you're going to look to see if you can't eliminate these two by adding them together. You can't eliminate them by subtracting. That means you can't get 0 by adding them. You can't get 0 by subtracting them. Let's look at this. There's a 1 that's automatically in front of this y. You can't add these two terms together to cancel out the y's or to get 0. And you can't subtract them either. Okay, so you can't use addition or subtraction. So now what we're going to do is look for the least common multiple to see how can we get them the same. We're going to use multiplication. So what can I multiply 5 by so that I can make these two the same? And I can do 2. The least common multiple for these is 2. It's 10. So I can multiply this by 2 to make this 10. And then they're the same. Here, I can multiply this by 7. And then these two will be the same. I would rather multiply by 2 than 7 because 2 is a smaller number. So I'm going to multiply everything by 2. The reason why you have to multiply everything by 2 is because if you just multiply this term, then you change the whole equation. But remember, if I do one thing to one side of the equal sign and the same thing to the other side of the equal sign, then my equation is still equal. So I'm really making an equivalent equation, okay? All right, so I'm going to multiply 2 times all of the terms. 2 times 5x is 10x. 2 times y is 2y. And 2 times 9 is 18. I can leave the second equation the same. Okay. Now I can eliminate the x's. So when I eliminate the x's, I have to subtract them to eliminate. So I'm going to use subtraction here. 10x minus 10x is 0. 2y minus a negative 7 gives me 9. Minus a negative is plus a positive. So this is going to be 9y. Bring down the equal. 18 minus 18 is 0. So I'm going to divide both sides by 9, and I get y is equal to 0. So my y coordinate, where the lines cross, is going to be 0. So now I have to figure out my x. I'm going to use the top equation, 5x plus y equals 9, to substitute, okay? All right, so I have 5x plus y is equal to 9. I'm going to substitute 0 for y. So I'm going to plug in. When I plug in 0, okay, I am left with 5. Oops. Yeah, that's right. I'm left with 5x is equal to 9. I'm going to divide both sides by 5, and I get x is equal to 9 over 5. Okay, so this is going to be 9 over 5. Remember, if I need to write this as a mixed number, I can divide my top number. My top number goes here, bottom number goes here. So 5 goes into 9 one time. That's 1 as a whole number. This gives me 4 remainder, so it's going to be 4 over 5. That's how you convert this to a mixed number if you need to, okay? Some people might have forgotten. This is card number 17, elimination method. Now we're going to do the matrix method, okay? And we did matrix a long time ago, but we might have forgotten, so I'm going to just remind you of how to do that. So we got EOC. Let me turn this card this way. It's going to be upside down, but that's okay. So we got EOC review. And this is number 3, systems of equations. This is card number 18. And here we're going to solve a system. We're going to solve by using matrix. And we need the calculator for this, okay? So this is the system. This is the system. The first equation, this is the second equation. All right, so now you can only use the matrix when you have them lined up. You got x is first, x has to come first, then the y term, then the constant on the other side of equal sign. It has to be set up in this order. So now you're going to do the matrix. The matrix that you're going to draw, a matrix by definition is a list or an array of numbers, okay? You have two rows and 3 columns. So 2 rows, 3 columns, okay? All right, so the first row is just write the numbers, not the variables. -4, -2, -12. The second row is 4, 8, and -24. Make sure it's lined up just like that. This is a matrix. This is a list or an array of numbers. Array is the same as saying a list. All right, so I'm going to clear my calculator. Second plus 712. Reset it. Second plus 7. You stroll over to all. 1, 2. All right, so now what you do is you go to matrix in the calculator. Notice how matrix is in yellow. So you press the second button and matrix here. Okay. All right, we're going to create a matrix. So go over to edit and press enter. And you're going to create a 2 by 3. 2 rows, enter, 3 columns, enter. Okay. So I'm going to type one number in at a time. -4, enter, goes over. -2, enter. -12, enter. +4, +8, and negative 24, enter. Press enter after every one. Make sure you press enter here. Go to the main screen, second mode. Go back to matrix, second matrix. And you want the calculator to do the work. So here you go over to math and you look for RREF. RREF. You might want to make a mental note to look for RREF. Okay, this is what you need to be looking for that. Okay. All right. So now press enter and go back to matrix, second matrix, and the one that we created. Press enter here, and then press enter once more. So this is what you see. So when you see this in the calculator, 10601 -6, your answer is these last numbers on the end. This first number is always going to be your X, and that last number right there is going to be your Y. So your ordered pair for X coordinate is 6, and your Y coordinate is -6. Oops, sorry. So this is going to be the solution. So this is another option you can use to solve a system is by using the matrix, okay? All right, y'all. Have a good one, okay? Bye.